Okay, welcome back Year 12s to the second lesson for the applications of the finance solver. It's a little bit of a mouthful, but what I want to do is run through how we can use the finance solver in other situations. So far we've just looked at the reducing balance loans, which there's loads of questions where we have to use the finance solver for those situations, but there's other situations that we can use the finance solver for as well. So whenever you come across this word here, an annuity, we are going to use the finance solver for that as well. So what is an annuity? Well, what we can do is we can give the bank a sum of money, invest that money in the bank, and what we can have is that money will earn interest, and the bank can pay us a little bit of money back when we however regularly we would like, in fact. So perhaps you've got a large sum of money, maybe you've won Tats Lotto or something like that, and you want that money to last as long as possible. What you could do is you could invest in an annuity, and then you could have that money earn interest, compound interest, and regularly withdraw from that account. So let's have a look at Joe. He's purchasing one of these. He's going to be giving the bank that $200,000 to invest. So 5% compound interest per annum. It's compounding monthly. So this is all information that's going to go into the finance solver. And he wants to be paid from that $200,000. He wants to be paid regular monthly payments for 10 years. So what we can do is work out how much he will actually get. If he wants this annuity to last 10 years, so you'll see that because when it says it's lasting 10 years, it's saying that the future value is going to reach zero, and he is going to run out of money. What we can do is work out how much he'll get for 10 years of payments. Okay, so to start off with, if we're going with 10 years and there's monthly payments, there's obviously 120 payments. The interest rate will be in per annum on the finance solver, so pop that in. Now, if he's investing this money, it's going to the bank. Remember, money that goes to the bank when we put in the finance solver is negative. Payment, that's what we're trying to find. Future value will be zero because the annuity will run out. It's monthly payments and it's compounding monthly. When you put all that information in and solve for PMT, you get a positive number. This is what we expect because he's going to get this money from the bank. And what you can see is that he receives $2,121.31 every month. Is received, sorry, that doesn't look right, does it? Every month. It's quite a decent amount of money for 10 years. Okay, second question. If he wants instead to have $3,000, how long will this last him? We want to answer to the nearest month. So what we'll do is, all of this is staying the same apart from payment. We're going to change payment and we're going to find what N is. So we'll change payment to $3,000. So instead of receiving $21.30, he wants to get $3,000. This means that it's not going to last as long. If he's being paid more, it means the money will run out faster. So let's find N now. Put that into the finance solver and you get N is 78.264. So this is equal to 78.264 months. And because it says round to the nearest month, this is simply 78 months. You can convert that to years if you want to. That would be 6 years, 6 months. Only do that if you are asked to do that. If I was actually asked how many payments, it's 78 payments, but there's a little bit left over. So really he'd be receiving sort of 79 payments altogether, but that last one's not going to be as big. When it says here to answer to the nearest month, you can round your N value appropriately. There's another situation I want to look at, and that is when you add to an investment. So you might, say, put a heap of money in a savings account and then add to that savings. So add regularly, and when you get paid, you might be putting a little bit extra into your savings each month. So we use the finance solver for these situations as well. Okay, so compound interest formula is only when there are no payments being made. Finance solver will help us out if there is. Okay, so here we have $500,000 being invested. So if you are investing the money, you're giving it to the bank. It's compounding monthly, so that's 12 in a year. He makes regular deposits of $500. So if he's giving it to the bank, again, negative. So both of these will be negative when you add to an investment. And that's per month, so that's 12 in a year. Future value, we want to know what that is. After 5 years, so 5 years of monthly repayments, that's 60 payments, and the rate is 5.5. So we have all of our information, and we are finding the future value. And you'll see it's quite large because he's going to be earning a lot of interest here. It's $500,000 at 5.5% per annum. So that is a hefty amount of interest. The investment is now worth so put your dollar sign in, $692,292.30. So that is when you add to an investment. Negative, if you are investing, it must be negative because you're giving it to the bank, and he's adding it to it, so he's giving more money to the bank to invest it, so another $500. Let's compare a couple of loans now. So now that we've done loans, done investments as well, if we wanted to compare different loans, there's a few things that we need to remember. One of those things is obviously if you increase the size of the repayment, you're going to pay off the loan faster. You can decrease the length of the loan, and this means that you're going to save interest. So you'll decrease the amount of interest. We have mentioned that in class quite a few times. If you increase how much you're going to pay back, this will obviously decrease the total amount of interest paid as well, because you can pay it off faster if you increase the frequency of your repayment. If the interest rate goes up, this will generally mean that the interest you are paying goes up as well. And unless you start to pay more on your regular repayments, the length of the loan will also increase. For that reason, if you want to maintain the length of a loan when interest rates do go up, what you have to do is increase the regular repayment, because the amount of interest is increasing. So to pay it off, or to have it paid off by the same date that you want to have it paid off by, you will have to pay a bit more each payment. Let's have a look at a comparing loans question. First of all, we've got that $10,000 is going to be borrowed, so that's our PV. He wants to pay it off over 5 years, so that's our time. It might be different for Finance Solver. Remember, we don't have time in Finance Solver, we have N number of payments. And there's two plans here. Flat rate of interest is 7.5%. That's a simple interest. Flat rate of interest is simple interest. Or interest at 10% per annum, reducing quarterly. That is a reducing balance loan. So we'll use Finance Solver for the second one, but the first one that we'll have a look at is just the simple interest formula. We want to look at the total repayments that will need to be made, and then we'll make a decision for which one is better. Okay, so for plan A, what we can do is work out the total amount that will be paid. Remember, total amount is A. So if 10,000 was borrowed, remember the flat rate was 7.5%, and that was for 5 years. And you'll see that $13,750 must be paid back. 10,000 was borrowed, so you can see the interest straight away, $3,750. Let's compare that though to Plan B, which is interest is at 10% per annum. 10,000 was borrowed. Now it's 5 years, and it says here reducing quarterly. So we can assume that there's quarterly payments as well because it doesn't specify. Okay, so reducing quarterly, so quarterly payments. What have we got in terms of time? 5 years and quarterly, that's 5 times 4. Payment, well, we're going to try and find that. And future value should be 0 because she wants to pay off the car in that time. When you do that, put that into Finance Solver, we get PMT. It's negative, we expect it to be negative as it's being given to the bank. So quarterly repayment is $641.47. What we can do is work out a total. If we take the payment and we multiply that by n, the number of payments, we can see that the total amount that must be paid equates to $12,829.40. So these are the two options we have. In one of those you must pay, Plan A you must pay $13,750. In Plan B it's a lot less, $12,829. So really, which one would you recommend? When it's a loan, you obviously want to go for the one that's costing you less. So Plan B is the better option. And why? Less interest is charged overall. If we're looking at an investment, you obviously want to go with the one that's highest because you want to earn the most money when you're investing it. But when you're borrowing the money, you want to pay the least amount, which is why in this case Plan B is better. I want to look at another type of loan that sometimes comes up, and that's an interest-only loan. So this is when you pay back just the interest that is charged. This means that the principal, or the amount that you borrowed at the beginning, it stays, it remains. You are not paying it off. So you still owe that amount. Until you start to increase your repayments, you will still owe what you borrowed at the beginning. Okay, so let's work out for this one what we're dealing with. So with interest-only loans, what you'll notice is if she borrows $500,000, that would be our PV. But because she's not paying any of it back, she's only paying for the interest, future value will be actually negative $500,000 because that's what she owes the bank. After any specified time period, after any value of n, that is how much she owes the bank, what she borrowed at the beginning. She is going to be paying monthly. She's going to pay the interest charge monthly. So that's 12, and it's compounding monthly as well. Payment is what we're trying to find. The interest is 6.65%. And what you put here for N with interest-only loans, it doesn't matter. You can just put, say, 12, looking at 1 year. Even if you just put number 1, it would still work. You'll get the same amount because she's paying this same amount back indefinitely until she can pay more, until she can start to reduce what she owes. So this is her monthly repayment. And that is just the interest that is charged. So over time, she will still owe that $500,000. So in a way, it's like she's sort of renting the $500,000 in a way. She's renting it, and this is sort of like a rental charge. to use that money. The last thing I want to look at is a perpetuity. Perpetuity is a type of annuity, but perpetuities will last forever or last indefinitely. And the reason is when you get open a perpetuity, what the regular repayment that you get, remember annuities have a repayment or a withdrawal, so money that you're getting from the bank. With a perpetuity, the money that you're getting is just the interest that has been accumulated. So what this means is the principal stays the same. Principal remains untouched. Therefore, it does not decrease at all. Despite you withdrawing from the perpetuity, it is not decreasing at all because you are only withdrawing the interest that it has earned. Now, for that reason, we can use some fairly straightforward formulas because the interest isn't compounding the way that we have learned before, because you were subtracting it, you're taking it away. So therefore, the interest isn't going to be added and then recalculated, because whenever interest is earned, it's then withdrawn to be spent elsewhere. So we've got a couple of really basic formulas for perpetuities, where P is the amount invested, so just here. R is our interest rate, and that'll be per annum, generally, and regular repayment, that's an annual payment. So that's what you're gaining from the bank. Let's have a look. So suppose Richard wants to start a scholarship where every year a student receives $1,000. So there's our Q value. So he wants to invest a sum of money that will earn $1,000 in interest every year, and then that money will be subtracted. It'll be subtracted from the investment, leaving P. And then the interest will be earned again in the next year, and that interest earned will then be subtracted. And that continues until, well, it will continue forever until you decide that you want to end it. And you can withdraw that money if you wish. What we can see is this amount of money here must be invested. If we put this amount of money into the bank at this rate of interest, we will see that it earns $1,000 every year. So we can be paid $1,000 every year, provided that money stays in the perpetuity. This one's dealing with a much larger sum. So we've got $500,000 invested. Now we want to know what the monthly payment is. So we're finding Q. Don't forget Q is annual. That will give us the annual payment. And R at this point is 6%. Now it does say that it's monthly and it's compounding monthly, but that doesn't matter because she's getting a monthly payment. So this means that every time the interest is earned each month, it's not going to be added to the investment. It's going to be withdrawn by Elizabeth and given to Elizabeth to spend. So to work out the annual payment, we go Q is equal to PR over 100. So that's 500,000 by 6 over 100. And what we'll see is she gets 30,000 in the year altogether. And if we want that per month, we just need to divide that by 12. So she's getting $2,500 per month. Finally, got Grandpa investing in a perpetuity where he'll get a monthly pension of $584. So our Q value, which is annual, that's going to be 584 multiplied by 12, which is 7,008. We want to know how much he's invested in the perpetuity, and it's 6.2% per annum. And there we have how much Grandpa has in his perpetuity. This would give him a yearly payment of $7,008, but as a monthly payment, it would be $584. So there's a lot there. Thank you for listening to the end of this video. Make sure you have a go at these questions. Obviously, it's very important that you get loads of practice in using the solver. If you are getting any mistakes wrong, please be careful. Check your negatives.